Hello everyone, World Math here. Today, Chiliang, Martin, Brian and me, Kieran, are going to talk about real-world applications of logarithms, specifically earthquakes in geography. In this amazing world of mathematics, logarithms is definitely one you should look out for. Be it calculating composition of drugs in medicine, or measuring pH values in solutions. Logarithms are efficient and are prevalent in today's day and age. In mathematics, the logarithm is the inverse operation to exponentiation. That means the logarithm of a number is the exponent which another fixed number, the base, must be raised to produce that number. In simple terms, the logarithm counts factors in multiplication. In earthquakes geography, logarithms are used to measure the intensity of earthquakes.
Now let's talk about earthquakes and how we measure their intensity. In 1935, Charles Richter defined the magnitude of an earthquake to be m equals to log I over s, where I is the intensity of the earthquake measured by the amplitude of a seismograph reading taken 100 kilometers from the epicenter of the earthquake, and S is the intensity of a standard earthquake whose amplitude is 1 micron equals to 10 to the power of -4 cm. The magnitude of a standard earthquake is m equals to log S over S equals to log 1 equals to 0. Richter studied many earthquakes that occurred between 1900 and 1950. The largest had magnitude of 8.9 on the Richter scale, and the smallest had magnitude 0. This corresponds to a ratio of intensities of 800 million, so the Richter scale provides manageable numbers to work with. Each number increase on the Richter scales indicates an intensity 10 times stronger. For example, an earthquake of magnitude 6 is 10 times stronger than an earthquake of magnitude 5.
Let's talk about why the chosen subject area of earthquakes is geography is important. Richter scale, which makes use of logarithms, is reliable and helps to calculate the intensity of the earthquake. Life without this would be akin to not knowing the topics for an exam. This is important as it involves the lives of people, as the wrong measurement of the intensity of an earthquake could lead to either overestimation or underestimation of the size of the tremor. This would cause serious and harmful consequences. For example, a high death toll as a result. Practically everyone in the world needs to know how to read the Richter scale, so as to gauge how devastating an incoming earthquake will be. This will allow them to make the adequate preparations for the incoming earthquake.
Seismology is the study of seismic waves, energy waves caused by rock suddenly breaking apart within the earth or the slipping of tectonic plates. The use of logarithms would be highly relevant to the job scope of this occupation.
In conclusion, logarithms has greatly improved the way we calculate various information, such as finding the growth rates of a country's economy, or even just finding the pH of a certain solution. It has even allowed us to improve many systems in our society to better fit the needs of the people, as well as improve safety measures in the country. Logarithms has certainly changed the way we view, perceive, and interact with the things around us. It has broadened our vision to find out and explore more of the uncharted territories in the worlds of math, science, and even geography. It is, without question, one of the greatest discoveries in mathematical history. It has been our greatest pleasure having you here today, and we hope to see you again next time. We are World Math, logging off.